Let's take a look at our practice test. We're told to solve each inequality, write in interval notation, and graph. We're going to look at problem number 1 first. So we have the absolute value of x minus 3. This is greater than the absolute value of 2x minus 5. So let's actually take this down to a little table, and we'll work on it there. And I'll show you how to set this up based on the interval that you're in. Okay, so the first thing is if you're going to solve this type of inequality, you need to consider a rule for when you're going to drop the absolute value bars. In other words, you would think about, is this guy inside of the absolute value bars, that expression, is it negative, is it 0, or is it positive? If it's negative, then you need the negative of that expression in that interval. If it's 0 or positive, you can just drop the absolute value bars. So you would say, where is this 0? So where is x minus 3 equal to 0? Well, you just add 3 to both sides of the equation, cancel that, you get x is equal to 3. So that's going to be one, what we call breakpoint. Okay, I'm just going to keep this here for right now. I'll fill in the table in a second. We need the other one. So let's look at this one. So this is 2x minus 5. So let's say 2x minus 5 is equal to 0. We'll add 5 to both sides of the equation. We'll cancel that. We'll say 2x is equal to 5. Divide both sides by 2. So you get x is equal to 5 halves. Let me just get rid of all this and write this more neatly. So x is equal to 5 halves. So you're going to use these two numbers to set up intervals on the number line. You first think about the leftmost value. So if I'm on the number line, 2.5 is to the left of 3. So what I'm going to do is first have my leftmost interval, I'll say coming from negative infinity, going up to and excluding 5 halves. Now, a lot of people get confused here when you start including or excluding things. So I'm just going to set this up and then I'm going to talk about why. So the next interval, if you look at it, it's going to be between these two values. So 5 halves and 3. But I'm going to actually include 5 halves here, and I'm going to exclude 3. And again, I'll talk more about this in a moment. And then the next interval would be anything that includes 3 and going out to positive infinity. So basically 3 or anything greater. So now we've basically split up our number line into 3 intervals. So anything that's strictly less than 5 halves, anything that's between 5 halves and 3, where 5 halves is included, and then anything that's 3 or larger. Now, what you're going to do is go through and think about in this interval here, where x is less than 5 halves, well, each one of these guys is going to be negative. So basically, instead of the x minus 3 here, when I drop the absolute value bars, I want the negative of the quantity x minus 3. And then when I drop the absolute value bars here, I want the negative of the quantity 2x minus 5. So that's going to be our rule in this interval. When we get into this interval here, you think about 5 halves itself. The reason it's included here is because 5 halves would make this guy, this expression, 0. So whether it's 0 or some positive value, you can just drop the absolute value bars. So this one right here would be 2x minus 5. And then in this interval, it's going to be positive, so it's just 2x minus 5. Okay, so if it's 0 or positive, just drop the absolute value bars. Now, in this interval here, this guy is still going to be negative. It's going to be 0 when it's 3, so that's not till here. So here it's negative, right, because we're less than 3. So we're going to say that this is the negative of this quantity x minus 3. Okay, now in this final interval, again, this guy right here starts at 3 and it includes 3. So this guy could be 0 or it's anything greater where this guy would be positive. So again, whether it's 0 or positive, just drop the absolute value bars. So this is just x minus 3. So one thing I want to touch on, if you worked on this with me where we solved equations, you saw that I actually excluded this. So I excluded 5 halves and I excluded 3. Now, I'm not going to do that in this situation because when you work with inequalities, you often have this overlap, and you're going to see that in this problem. So I think in this situation, this is better, although you could still make it work with this one. I think it's a little bit more challenging to think about it that way, so I'm just going to just work with it this way for this type of problem. Let's start out in the leftmost interval, or where x is less than 5 halves. So again, I'm going to basically replace this guy right here with this guy right here. So I want the negative of the quantity x minus 3. That's my rule for dropping the absolute value bars there. Then this is greater than. I want to replace this guy right here with this guy right here. So the negative of the quantity 2x minus 5. So let's come down here. We'll go back up in a minute. So just distributing the negative, this is negative x and then plus 3. This is greater than. This is negative 2x and this is plus 5. What I'm going to do first is add 2x to both sides of our inequality here. This is going to cancel. And then I'm going to subtract 3 away from each side of the inequality here. This is going to cancel. So negative x plus 2x is going to be x, and this is greater than 5 minus 3 is going to be 2. So here we have that x is greater than 2. So I want to think about that with you. Let's erase everything first. So the way this works, when you get a solution, you come into your interval. Let's just write x is greater than 2 here. And you would say, is this in this interval? So if I think about 5 halves, that's 2.5. If I said that x is greater than 2, what I would have here is a partial solution, right? Because it has to be in the interval. So basically, x would be greater than 2, but it would also have to be less than 5 halves because you have that cutoff there. So we're going to replace this and say that x is greater than 2 and less than 5 halves so that we can stay in this interval. Now, I move on to the next interval, and I think about what we have here. To replace this guy right here, I'm going to use this guy right here. So this is the negative of the quantity x minus 3, and this is greater than. To replace this, I'm going to use this one. So it's just going to be 2x minus 5. Okay, so this right here is going to be negative x and then plus 3. And this is greater than 2x minus 5. So here I'm going to subtract 2x away from each side of the inequality. This would cancel. Let's subtract 3 away from each side of the inequality. This is going to cancel. So we'll come up here. Negative x minus 2x is going to be negative 3x. This is greater than negative 5 minus 3 is going to be negative 8. What I'll do from here is divide both sides of the inequality by negative 3. This will cancel. We'll get x is, remember, this has to get flipped here because we divided by a negative. So this is less than. Negative over negative is positive. This is going to be 8/3. Now, is this in this interval? Well, yes. 8/3 is going to be 2 2/3. So that is, if you think about 5 halves, that's 2.5. That is a larger value than 2.5, and it is a smaller value than 3. So we're good to go there. But what you have to consider, again, is if you're going down to the left, you have to stop at this 5 halves. Now, you would include 5 halves here because it's included. So what you would do is you would say that x is greater than or equal to this 5 halves and less than, and this is going to be strictly less than, this 8/3. So you can see that we're going to be able to merge these two, and we'll talk more about that in a moment. Now let's work on this last interval here. So here, everything is going to be non-negative. So this is 0 or positive, and this guy right here would be positive, right? So I can just drop the absolute value bars and just solve x minus 3 is greater than 2x minus 5. So what we'll do is add 3 to both sides of our inequality. We'll cancel this. We're going to subtract 2x away from each side of the inequality. Let's cancel this. X minus 2x is negative x. This is greater than negative 5 plus 3 is negative 2. Let's divide both sides by negative 1. So this is going to get flipped. This is a less than. So here we basically have x is less than negative 2 over negative 1 is 2. So we have x is less than 2. Okay. Is this in this interval? No. This guy has a smallest value of 3. 3 is included, or anything larger, right? This is x is less than 2. This is not in this interval. So basically you just reject that solution, right? You don't even consider it. So now what we want to do, I'm actually just going to erase this so I have enough room. You're going to take these two guys and you're basically going to merge them with the keyword or. Okay, so you're going to say that x is greater than 2 and less than 5 halves, then or. You're going to say x is greater than or equal to 5 halves and less than 8/3. Now, if you think about this, this is basically where x is going to be greater than 2 and less than 8/3, which is this 2 2/3, right? Because the 5 halves is actually included here, okay, even though it's excluded here. So that's how that works. So what I'll do is say that my final answer is x is greater than 2 and it's going to be less than 8/3. So let's grab this. Now, typically when you solve this type of problem, they're going to ask you to write the solution in interval notation. So let's put a parenthesis next to 2 because it's not included. And let's put a parenthesis next to 8/3 because it's not included. All right, now in terms of graphing this, let's put a 2 here and then an 8/3 here. And then I'm going to use a parenthesis at 2 to show that it's excluded and a parenthesis at 8/3 to show that it's excluded. Again, you can always use an open circle. Your book may do that instead. So let's shade this in. So basically we're showing that x can be anything that's larger than 2 going up to and excluding 8/3. All right, so if you're struggling with this concept, you can always graph this using a free online graphing calculator. I would recommend something like Desmos. I'm using MathGV, which is something that's also free. So let's first think about what we had. We had the absolute value of x minus 3, and we said this is greater than the absolute value of 2x minus 5. Now, we haven't talked too much about graphing in this course yet, but hopefully you remember some of this stuff from Algebra 1. Essentially, this guy in green, this is y is equal to the absolute value of x minus 3. This guy in purple, this is going to be y is equal to the absolute value of 2x minus 5. So you're just looking at the graph of each and you're saying, hey, where is this green graph above this purple graph, right? So you can see here it's below, 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 below. And you'll see that at 2, they're going to intersect. And they're also going to intersect. This is going to be that 8/3 that we talked about, or the 2 2/3. And then everywhere outside of that, it's going to be below. So you can see that this piece right here, between this 2 and 8/3, it's actually going to be above the purple graph, where it has a higher y value or function value for those given x values. So that is true where x is greater than 2 and less than 8/3. Again, at 2 and 8/3, they're equal. So this is a strict inequality, so you have to use strict inequalities here. So that's how you could get your solution graphically. All right, let's take a look at problem number 2 now. So we have the absolute value of 3x minus 4 is greater than the absolute value of x minus 2. So let's just write that really quickly. So again, the absolute value of 3x minus 4 is greater than the absolute value of x minus 2. Okay, so once again, I'm going to work on a table. If you want to use a number line, that's fine. But we're just going to split this into different intervals. Now, we get the intervals from, again, thinking about what's inside of the absolute value bars. You're going to set that equal to 0. So, for example, here, 3x minus 4, if I set that equal to 0, we add 4 to both sides, cancel this, you get 3x is equal to 4. Divide both sides by 3, we'll cancel that. So x is 4/3. So let me just put x equals 4/3, and this is just scratch work. I'm going to erase that in a moment. The other guy is this x minus 2. So x minus 2 equals 0, add 2 to both sides, and you get x is equal to 2. So you're using these two numbers here to split the number line up into 3 intervals. Okay, so you think about the leftmost value. The leftmost value here is 4/3, right? It's 1 1/3, that's less than 2. So you're going to create this interval here coming from negative infinity and going up to and excluding this value. So excluding 4/3. You want something where both of these are going to be negative. You don't want to include 4/3 because this would make this 0. Okay, so they both have to be negative in this first guy. Then here, this is going to be between these two values, but I'm going to include 4/3 and I'm going to exclude 2. And the reason I'm doing that is if I include 4/3 for this one, it's 0, and that's okay. Because if this guy is 0 or some positive value, it's the same rule. I can just drop the absolute value bars. But I don't want to include 2 here, because if I did, well then here at 2, this is 0. It's a different rule than if it was negative or less than 2. So the last interval would include 2 and go out to positive infinity. Okay, so we've split the number line up into these 3 intervals. So what we are basically doing is just getting a rule for dropping the absolute value bars in each interval. So in the leftmost interval where we're strictly less than 4/3, this expression is negative and this expression is negative. We know that. So basically you replace this guy right here with the negative of the quantity 3x minus 4. You replace this guy right here with the negative of the quantity x minus 2. Now, when we move to the right in this next interval, 4/3 is included. So that makes this guy 0 here. And then we're going up to but excluding 2. So between 4/3 and including 4/3 and 2, this guy is either 0 or positive. And whether it's 0 or positive, you just drop the absolute value bars. So it's just 3x minus 4. Then when we get to 2 or larger, it's going to be positive, right? So it's 3x minus 4 here as well. So then when we think about this x minus 2 here, this is negative in this interval, okay? And that's because we're at less than 2. That's why we didn't include it here. So this is the negative of the quantity x minus 2. And then here, because we're including 2, it can be 0 or anything larger where it would be positive. So for that, if it's 0 or positive, just drop the absolute value bars. So this is x minus 2. Okay, so this gives us our setup. And once we've done all this work, we just go through and set up our inequality in each interval, see if it fits in the interval. If it does, we can accept it. If it doesn't, we can reject it. And then at the end, we're going to think about everything together and try to merge. So we're going to think about this first guy where both of these are negative. So I want the negative of the quantity 3x minus 4. And this is going to be greater than the negative of the quantity x minus 2. So here you could distribute the negative into each, or you could just divide both sides by -1. And flip the direction of this. Again, that doesn't really matter, but this would cancel, and you would have 3x minus 4. I'm going to flip this to a less than, and this is x minus 2. Maybe that's quicker, maybe it's not. It just depends. Let me show this as canceling so nobody's lost. So from here, I'm just going to subtract x away from each side of the inequality, and I'm going to add 4 to both sides of the inequality. So let's show this is canceling and this is canceling. If we think about 3x minus x, that's 2x, and this is less than. -2 plus 4 is +2. We'll divide both sides of the inequality by 2. That will cancel. And you'll get x is less than 2 over 2 is 1. So we get x is less than 1. So coming back up and thinking about this interval is x is less than 4/3. So that's 1 1/3. If I put x is less than 1, that's in that interval. So you don't have to do anything there at all. So for this next one, this guy is going to basically be either 0 or positive. So we just drop the absolute value bars. And then this guy right here is going to be negative. So I want the negative of the quantity x minus 2. So let's go 3x minus 4 is greater than, you can just distribute this now. This is the negative of x and then plus 2. We will say that we'll add x to both sides of our inequality, add 4 to both sides of our inequality. And so this cancels and this cancels. 3x plus x is 4x. And this is greater than 2 plus 4 is going to be 6. Let's divide both sides of the inequality by 4. So this is going to cancel. And we have x is greater than. For 6 and 4, they're each divisible by 2. 6 divided by 2 is going to be 3. And 4 divided by 2 is going to be 2. So you get x is greater than 3/2. So let's put x is greater than 3/2. But there's an issue here. You can't just have x is greater than 3/2 because it has to be in this interval. Now, 3/2 is greater than 4/3, right? 4/3 is 1 1/3. 3/2 is 1.5. You would just want to adjust it to cut it off to stay in the interval. So you would say that x is greater than 3/2, and you have to say that it's less than 2 because you have to stay in this interval. Now, again, you might get something over here that works. I'm going to tell you in advance you do. So you're going to end up including 2, but we're not going to do it just yet because we're not there yet. Now, over here, everything is non-negative. For this one, it's 0 or some positive value. For this one, it's positive. So in each case, you can just drop the absolute value bars. So you would have 3x minus 4 is greater than x minus 2. Let's subtract x away from each side of the inequality. Let's add 4 to both sides of the inequality. Let's cancel this and cancel this. And we'll say that 3x minus x is 2x. And this is greater than -2 plus 4 is going to be 2. Let's divide both sides of the inequality by 2. We'll cancel this and say x is greater than 2 over 2 is 1. Okay, so let's come back up here. And I'm going to write x is greater than 1. Now we have to be in our interval, and remember the smallest value here in the interval is 2. So I'm just going to adjust my solution to account for that and say here x is greater than or equal to 2. Okay, so now we're ready to put everything together. Let's get rid of this. We don't need it anymore. And you're going to put everything together with the keyword or. So you're going to say that x is less than 1, then or. You're going to say that x is greater than 3/2 and less than 2. Then you're going to say or x is greater than or equal to 2. Now, this part right here on the left is straightforward. X is less than 1. Nobody's going to get lost on that. But this part right here, I think would trip a lot of people up. So let's spend some time on it. And basically, you want to think about the fact that here, x is greater than 3/2. So let me start by just writing that. So x is greater than 3/2. Then you say and less than 2. Okay, but then you have the keyword or here, and you're saying x can be 2 or anything larger. So really, it's kind of like you can get rid of this part from this statement here. And if you considered x is greater than 3/2 or x is greater than or equal to 2, well, then it's just x is greater than 3/2. So you can actually just get rid of this altogether and write your solution as x is less than 1 or x is greater than 3/2. And I know that was confusing, but you might need to just pause the video, really think about what's going on. You can draw this out on a number line and consider everything. So let's grab this. So I'll say coming up from -infinity and going up to but excluding 1. So make sure you use a parenthesis with 1. And then it's the union with, you're going to use a parenthesis with 3/2 because it's not included. So anything larger than that, so that's going to go out to positive infinity. So graphically, you could find 1 on the number line. I'm just going to put a 1 here and then 3/2. I'll just put the 3/2 here. And then basically, I'm going to use a parenthesis with 1. And then I'm going to shade everything to the left here. And then I'm going to use a parenthesis with 3/2. And I'm going to shade everything to the right here. And remember, you can always use an open circle instead of a parenthesis if that's what your book does. So we can see graphically that x can be anything that is less than 1, or x can be anything that's greater than 3/2. All right, so once again, if you're struggling with these types of problems, you can graph them, use Desmos. We had the problem where we said the absolute value of 3x minus 4 is greater than the absolute value of x minus 2. So graphically, we could say this guy in green is y is equal to the absolute value of 3x minus 4. And this guy in purple, we could say this is y is equal to the absolute value of x minus 2. So basically what we're saying is where is the green graph, or again, the graph of y equals the absolute value of 3x minus 4, where is that above the purple graph, or the graph of y equals the absolute value of x minus 2? We can see where they cross, and that's going to be important. So we have this 1 right here in terms of this x value. That's where the y values or the function values would be equal. And then also you have this other crossing point. This is going to be 3/2. Remember, we saw that. Everywhere to the left of 1 in terms of the x value, this green graph is above this purple graph. We can all see that. And everywhere to the right of this 3/2 in terms of the x value, the green graph is again above the purple graph. So graphically, we can say the solution is x is less than 1, or x is greater than 3/2, okay? If this guy had been flipped and it was a less than, well, then you're talking about this piece in between, right? So there it would be that x is greater than 1 and less than 3/2. So again, really easy to see what's going on when you graph these guys. I strongly suggest this if you're struggling with these problems. All right, let's move on now and look at problem number 3. So we have x plus 3 is greater than or equal to, we have the absolute value of 2x minus 3, and then plus 1. So with this one, we don't have two absolute value operations. We only have one. So it's going to make it a little bit easier. Let's just copy the problem. So we have x plus 3 is greater than or equal to the absolute value of 2x minus 3, and then plus 1. Now, because we have this x here that's outside of the absolute value bars over here, we still have to do a little bit more work. So we have a table here, but it's just going to be 2 intervals. Okay, so we don't need 3 intervals here. So you're just going to consider, now let me unhighlight this so nobody gets confused. You're just going to consider where 2x minus 3 is equal to 0. And then basically, let's set that up. So 2x minus 3 is equal to 0. Let's add 3 to both sides. Let me make that 3 a little bit better. We'll cancel this. We get 2x is equal to 3. Divide both sides by 2. We get x is equal to 3/2. So we know if x is less than 3/2, so basically coming from negative infinity, going up to but excluding 3/2, that this guy right here, this expression is going to be negative. So we want the negative of the quantity 2x minus 3. So that's the rule if we drop the absolute value bars. Now, anything where we are at 3/2 or greater, well, this guy would be 0 or some positive value, so we could just drop the absolute value bars. So I'm going to include 3/2 here and go out to positive infinity. And so here it would just be 2x minus 3. So we have our rule, and we just have to solve 2 inequalities. So let's see with the first one, I have x plus 3 is greater than or equal to. We'll replace this guy with this guy. So I have the negative of the quantity 2x minus 3. And then basically we have plus 1. Okay, so we have x plus 3 is greater than or equal to. Let's go the negative of 2x, and then plus 3, and then plus 1. Now you notice that you have 3 here and 3 here. You could subtract 3 away from each side of the inequality. Let me actually just show that so that nobody is lost. And I'll cancel it like this so it's a little bit more clear what's going on. Okay, from here I'm going to add 2x to both sides of the inequality. And I'll cancel this. And so what do we have left? We have x plus 2x, that's 3x. This is greater than or equal to 1. We'll divide both sides of the inequality by 3. This will cancel. And you get x is greater than or equal to 1/3. So let's put that x is greater than or equal to 1/3. Is that in our interval? Well, remember, the interval is basically going to be anything that's less than 3/2. So 1/3 would be in this interval. The only problem is when you write it, you want to stop at anything that's less than 3/2. So you would say that x is greater than or equal to 1/3 and less than 3/2. So that's what we want to do there. Okay, for the next guy here, you're just going to drop the absolute value bars. So I'm just going to get rid of this and solve this inequality and see what that gives us. So here I will subtract 2x away from each side of the inequality. Cancel this. Let's subtract 3 away from each side. And so this would cancel. And we'll say x minus 2x is negative x. This is greater than or equal to. You basically have negative 3 minus 3, which is negative 6. And then plus 1, that's going to be negative 5. Let's divide both sides of the inequality by negative 1. So this cancels. We're going to flip this because we divided by a negative. So this is a less than or equal to. Let me write my x in there. And negative 5 over negative 1 is 5. So you get x is less than or equal to 5. So let's write in here that x is less than or equal to 5. Now, again, you have to consider that this interval is going to start at 3/2. So I'm going to basically rewrite this and say that x is greater than or equal to 3/2 and less than or equal to 5. So if you put these two together, you're basically saying that x is greater than or equal to 1/3 and less than 3/2, then or x is greater than or equal to 3/2 and less than or equal to 5. Well, this guy right here includes the 3/2, right? So 3/2 is included. So basically, if you put these together, you would say that x is greater than or equal to 1/3 and less than or equal to 5. Okay, so let's just get rid of this, and I'll just slide this down. So that would be your answer. So x is greater than or equal to 1/3 and less than or equal to 5. So in interval notation, we're going to put a bracket next to 1/3 because it's included. And then I'm going to put a bracket next to 5 because it's included. So basically, it's between 1/3 and 5 where both are included. That's all we're saying. Let me put a 1/3 here and a 5 here. And so I'm going to put a bracket here at 1/3 to show it's included, and a bracket here at 5 to show that it's included. Again, if you want to use a filled-in circle, if your book does that, that's fine. It means the same thing. And so I'm just going to shade everything in between. So x here graphically can be 1/3 or anything going up to and including 5. All right, so once again, you can look at this graphically. So you're going to graph this guy in green here. This is just a simple linear equation in two variables. This is y is equal to x plus 3. A lot of us know how to graph that already. So the y-intercept is at 0, 3, and the slope is 1, right? So go up 1 to the right 1, so on and so forth. Then this other part here, the part on the right, this is this guy in purple. This is y equals the absolute value of 2x minus 3, and then plus 1. Okay, so if you don't know how to graph this, again, you can just use a computer-generated graph for right now. We'll talk about how to graph this stuff later on in the course. But I just want you to see that basically I'm asking, where is this guy, this x plus 3, or this y equals x plus 3, or this green graph above or equal to this other guy here, this y equals the absolute value of 2x minus 3 plus 1, this purple graph? Well, you can see they're equal here and here, right? And so this right here, the x value would be 1/3. And this right here, the x value would be 5, right? So that's where they're equal. And then essentially, between those two values, you can see the green guy is going to be above the purple guy, but nowhere else, right? So we could say that the solution graphically is that x is greater than or equal to this 1/3 and less than or equal to 5. So this is exactly what we saw from solving the problem. All right, let's take a look at problem number 4 now. So we have the absolute value of 5x plus 12 is greater than the absolute value of x minus 9, then plus 1. All right, let me copy this. So the absolute value of 5x plus 12 is greater than the absolute value of x minus 9, then plus 1. So again, we're back to having two absolute value operations. So I've got to set this equal to 0 and solve, and set this equal to 0 and solve. So let's go 5x plus 12 is equal to 0. I'll subtract 12 away from each side. I'll cancel that. 5x is equal to negative 12. And so what I'll do here is divide both sides by 5. We'll cancel this and say x is going to be negative 12/5. So I'm just going to write this right here. It's just scratch work. I'll move it in a second. Let me get the other one going. So this is just x minus 9 is equal to 0. And of course, we just add 9 to both sides of the equation. We cancel that and we get x is equal to 9. So the leftmost value here is this negative 12/5. So I'm going to say that coming from negative infinity, going up to and excluding negative 12/5. And then again, here I'm going to include negative 12/5. And we're going to go up to and exclude 9. And then here I'm going to include 9 and then anything larger. All right, so we've got the intervals going. In this leftmost interval, we know both of these guys are going to be negative. So I want the negative of the quantity 5x plus 12. Let me just speed this up and say this is negative 5x minus 12, just so we don't have to deal with that. So let's get rid of this and scooch that up. And then basically in this interval here, this guy is going to be 0 or some positive value. So I can just drop the absolute value bars. So this is 5x plus 12. And then again, here it will be positive. So this is 5x plus 12. Okay. For the other guy, this x minus 9, in this first interval, in the second interval, it's going to be negative. So you want the negative of the quantity x minus 9, which is negative x plus 9. So negative x plus 9, and then negative, let me make that better. So negative x plus 9. Okay, here it's either going to be 9 where it's 0, or it's going to be some positive value. So in that situation, you can just drop the absolute value bars. So it's just x minus 9. Now we just have to go through and solve our inequalities. So for the first interval, I'll just say negative 5x minus 12 is greater than, you'll have this negative x plus 9 and then plus 1. So 9 plus 1 is 10. Let me just replace that now. And so really quickly, I could just add 12 to both sides of the inequality. Let's cancel this. I'm going to add x to both sides of the inequality. Let's cancel this. And let's say negative 5x plus x is negative 4x. This is greater than 10 plus 12 is going to be 22. Let's divide both sides of the inequality by negative 4. We'll cancel this and say x is less than. Let me show this. The reason I flipped this again is because we divided both sides by a negative. And then 22 over negative 4, we know that's negative. 22 divided by 2 is 11, and 4 divided by 2 is 2. So this is negative 11 halves here. So let me grab this. So coming back up here, this guy will be within this interval. If you do negative 12 divided by 5 on your calculator, you get negative 2.4. If you do negative 11 divided by 2 on your calculator, that's negative 5.5. So this solution, we can just accept it. We don't need to modify it in any way. So for this guy right here, we can just say that 5x plus 12, just drop the absolute value bars, is greater than, here I want the negative, so negative x plus 9 and then plus 1. So again, 9 plus 1 is 10, so let me just replace that real quick. And so we'll add x to both sides of the inequality, that cancels. We'll subtract 12 away from each side of the inequality, that cancels. So if you have 5x plus x, that's 6x, and this is greater than, 10 minus 12 is negative 2. Let's divide both sides of the inequality by 6. This will cancel. We get x is greater than, we know this is negative. If you have 2 over 6, each is divisible by 2. 2 divided by 2 is 1, and 6 divided by 2 is 3. So x is greater than negative 1/3. So we have x is greater than negative 1/3. Now, again, negative 12 divided by 5, that's negative 2.4. If I think about negative 1/3, that is greater than this, so I'm okay there. But again, you can only go up to anything that's less than 9 to stay in this interval. So I'm going to say that x is greater than negative 1/3 and less than 9, just to make that work in the interval. Over here, let's solve this one. So we're going to have 5x plus 12, and then this is greater than your x minus 9, and then plus 1. So we're just dropping the absolute value bars here. So negative 9 plus 1 is going to be negative 8. I'm just going to replace that, and then what I'll do is subtract 12 away from each side of the inequality. That cancels. Let me subtract x away from each side of the inequality. That cancels. So we think about 5x minus x, that's going to be 4x, and this is greater than. Negative 8 minus 12 is going to be negative 20. Let's divide both sides of the inequality by 4. So we're going to cancel this with this and say that x is greater than, we know this is a negative, 20 divided by 4 is 5. So x here is greater than negative 5. So we got a solution of x is greater than negative 5. Now, for this interval, this would only come into play once we got to 9. So we would only think about this as x is greater than or equal to 9, because again, the rest of that is not in this interval. Okay, so we will get rid of this and use this. Okay, so let's put our solution together. And this is where people get confused. Let me erase this so I have some room. So I'm going to start with x is less than negative 11 over 2. That's easy. Then you're going to go or. This is where it gets complicated. So you have x is greater than negative 1/3 and less than 9. Then you have or again. You have x is greater than or equal to 9. So I know this part right here is super confusing for a lot of students. But just pause the video for a moment and just think about it. What's going on here? So this part is simple enough. So x is less than negative 11 over 2. That's easy to understand. But here, I want you to think about the fact that although you have this x is less than 9 here, here you have x is greater than or equal to 9. So really, you could just get rid of this, right? You could just not think about that. So if I had x was greater than negative 1/3, then or x is greater than or equal to 9, well, again, this is or, so it can work in either. So I'm going to take the least restrictive, right? So I'm going to go with x is greater than negative 1/3. So really, you can get rid of this and just say or x is greater than negative 1/3. And in interval notation, so basically anything coming up from negative infinity, going up to but excluding negative 11 halves, I'll use a parenthesis there. And the union with anything that's larger than negative 1/3, so I'll use a parenthesis there. So this is going out to positive infinity. So let's say this is negative 11 halves, and this is negative 1/3. And again, I'm going to use a parenthesis to exclude things. You can use an open circle if your book does that. So I'm just going to put a parenthesis here facing to the left, shade to the left, and put a parenthesis here facing to the right, shade to the right. So graphically, x is anything that's less than negative 11 halves or anything that is greater than negative 1/3. All right, so once again, if you're a little bit lost in this problem, you can always graph it. So you're going to take the left side here. This is y equals the absolute value of 5x plus 12. So that's going to be this guy in green. And then the right side here, this is going to be y is equal to the absolute value of x minus 9 and then plus 1. And this graph is cut off a little bit because it's kind of hard to display, but this would keep going up like that. It forms a V shape. But essentially what you look at here, we're saying where is the green graph above the purple graph? You can see where they intersect, so that's going to be here. And if you come down to the x value for that, it's going to be, let's say, negative 5.5 or negative 11 halves. I know that's not perfectly aligned there, but let's just say that's good enough. And then here, this is going to be our negative 1/3. Again, it's not perfectly aligned, but you can see that's where it is. And then basically, you can see that between these two values, the purple graph, or the right side here, is actually above the green graph. But that's not what we want. We want the green graph to be above the purple graph. So that occurs anywhere to the left of negative 11 halves. So again, we found that as x is less than negative 11 halves. And that also occurs anywhere to the right of negative 1/3. So we'd say, or x is greater than negative 1/3. Okay, so this is how you can look at this graphically and make that a little bit better and find your same solution. If you're confused about something, it's always good to stop and look at the graph. All right, let's take a look at problem number 5 now. So we have the absolute value of 3x minus 5, then minus the absolute value of 2x minus 7. This is greater than or equal to 6. So again, coming to our table, we just want to think about where 3x minus 5 is equal to 0 and where 2x minus 7 is equal to 0. So we'll say 3x minus 5 is equal to 0. We'll add 5 to both sides of the equation. We'll cancel that and say 3x is equal to 5. And then we'll divide both sides of the equation by 3. So we get x is equal to 5/3. Let me get rid of this. And then the other guy, we have 2x minus 7. So we'll say 2x minus 7 is equal to 0. Let's add 7 to both sides and cancel this. We get 2x is equal to 7. Divide both sides by 2. This cancels. And we get x is equal to 7 halves. Okay, so if we think about 5 divided by 3, that's basically 1 2/3. And if I think about 7 halves, that's 3.5. So 5/3 is the smaller value. So let's say this first interval is coming from negative infinity, going up to, and again, excluding the 5/3. Let me make this 5 a little bit better here. Then for the next interval, I will include 5/3, and I'm going to go up to but exclude 7 halves. And then for the final interval, I will include 7 halves, and I will go out to positive infinity. All right, so we already know how this works. In the leftmost interval, they're both negative. So I'm going to want the negative of the quantity 3x minus 5. So I want negative 3x, so negative 3x, and then the negative of negative 5 is plus 5. So all I did was I distributed a negative to each term here. Then this one would also be negative. So let's say this is the negative of 2x, and the negative of negative 7 is going to be plus 7. So this first interval is done. Now in the second interval, we would say that this guy right here would be non-negative, right? If it's 5/3, then it's 0. Any other value would make it positive. So you could just drop the absolute value bars. So this is just 3x minus 5 here. In this interval, this guy's positive. So again, just drop the absolute value bars, same rule. So 3x minus 5. Now for this guy, it's still going to be negative in this interval. So this is negative 2x plus 7. But then once we get here, it's non-negative, right? If it's 7 halves, then it's 0. Anything larger is positive. Again, same rule for that. So just drop the absolute value bars. It's 2x minus 7. All right, let's go ahead and set this up. So in the first interval, we're going to have negative 3x plus 5 in the place of this guy. Then you have this minus here. And this is where you have to be really careful. You have to wrap whatever you're going to put here in parentheses. So I'm going to say minus the quantity negative 2x plus 7, because this whole thing's being subtracted away. Then this is greater than or equal to 6. At this point, I'm just going to say this is negative 3x plus 5. The negative gets distributed to each. So this is plus 2x and then minus 7. This is greater than or equal to 6. So if you have negative 3x plus 2x, that's going to be negative x. And then 5 minus 7 is going to be negative 2. And again, this is greater than or equal to 6. Let's add 2 to both sides of the inequality. Let's cancel this away. We'll say negative x is greater than or equal to 6 plus 2 is going to be 8. If we divide both sides by negative 1, remember to flip the direction of the inequality symbol here. This would give us, this cancels, x is less than or equal to 8 divided by negative 1 is going to be negative 8. So x is less than or equal to negative 8. So coming back up here, we have x is less than or equal to negative 8. And does that fit in this interval? Yes, it does. So we can take this solution. Okay, for the next one, we're in this interval here. So let's think about dropping this and saying we have 3x minus 5. Then minus, you have to be really careful with this minus sign again. You're going to take this and put it in this place. So this would be the quantity negative 2x plus 7. And this is greater than or equal to 6. Let me make this a little bit better here. So we have 3x minus 5. and then the negative of negative 2x is plus 2x, and then the negative of 7 is just minus 7, and this is greater than or equal to 6. So negative 5 minus 7 is negative 12, and 3x plus 2x would be 5x. So this is 5x minus 12 is greater than or equal to 6. Let's add 12 to both sides of the inequality. This cancels. You get 5x is greater than or equal to 6 plus 12 is 18. If we divide both sides of the inequality by 5, this cancels, and you're going to have that x is greater than or equal to 18 fifths. Okay, so let's write x is greater than or equal to 18 fifths. Now, does this work? Well, actually, no. It's not going to be in this interval. You can cross it out. If you divide 18 by 5 on your calculator, you get 3.6. And remember, we're thinking about this 7/2. This is 3.5, right? So this value right here is outside of this interval, so you just reject it. Okay, let's look at this interval here. So in this case, we could just drop the absolute value bars. But again, you have to be really careful with that minus sign. So let's say this is 3x minus 5, and then minus the quantity 2x minus 7, and this is greater than or equal to 6. So we'll have 3x minus 5, and then you'll have minus 2x, and then plus 7, and this is greater than or equal to 6. So here, 3x minus 2x would be x. Negative 5 plus 7 is going to be 2. So let's put plus 2. This is greater than or equal to 6. For this one, let's subtract 2 away from each side of the inequality. This cancels, and we'll say x is greater than or equal to 6 minus 2 is 4. So let's put x is greater than or equal to 4. And this is in my interval, right? This starts with 3.5 or 7/2 and continues out to positive infinity. So I'll just say x is greater than or equal to 4 is something I can accept. Let me get rid of this, and we'll just write our solution. So here it's pretty easy. We just say x is less than or equal to negative 8, or x is greater than or equal to 4. Okay, in interval notation, I'm going to say coming from negative infinity, going up to and including negative 8. So you want a bracket next to negative 8. And then the union with, you want a bracket next to 4 since it's included. And it's going to go out to positive infinity, and then just put a parenthesis there. Okay, so at negative 8, it's going to be included. So I'm going to put a bracket there. Again, you can use a filled in circle if that's what your book does. We're going to shade everything to the left. And then at 4, we're going to put a bracket there, or once again, you could use a filled in circle. And then I'm just going to shade everything to the right. So graphically, x could be negative 8 or anything less, or x could be 4 or anything greater. So this graph right here in green, this is, you could say y is equal to the absolute value of 3x minus 5, then minus the absolute value of 2x minus 7. So you're trying to see where this guy is greater than or equal to 6. So you're looking for a y value of 6, so that's right here. So you come over, I'm just going to see where it intersects. So that's going to be right here, that's an x value of 4. And also going over here, that's going to be an x value of negative 8, right? And that's what we found. So basically at negative 8 or at 4, it's going to be equal to 6. And then anything to the right of 4 in terms of the x values, you can see that you're going to be above 6. So you could say x is greater than or equal to 4. That's that part. And then let me put or here. The other part is, again, if you're at negative 8 or anything less, you're going to be above 6. So let me actually slide this down just a little bit. I'll say also that x is less than or equal to negative 8. So again, that's how you could get your solution graphically. All right, let's take a look at problem number 6 now. So here we have a problem with nested absolute value. So we have the absolute value of, and then the absolute value of 2x minus 1, then plus 3. This is going to be less than or equal to 4. All right, so this one is a bit tricky, and we didn't do a problem like this in our lesson. But remember, in the previous section, we talked about how to solve an absolute value equation of this type. So we're just going to extend that now to working with an inequality of this type. And the idea here is to first think about this guy right here. So I'm just going to say that that's some algebraic expression u. And if I had the absolute value of some algebraic expression u, and if it was less than or equal to some positive number 4, well, we know this sets up to say that u is greater than or equal to negative 4, and it's less than or equal to positive 4. So, okay, we just have to translate that here. So this is my u here. So I would say the absolute value of 2x minus 1, then plus 3, is going to be greater than or equal to negative 4, and less than or equal to positive 4. So this is going to be my setup. Now, because this is a 3-part inequality, you can first subtract 3 away from each part. So remember, you have to do it to each part. I'm going to cancel that. Negative 4 minus 3 is negative 7. And we'll say this is less than or equal to. This is the absolute value of 2x minus 1, which is less than or equal to. 4 minus 3 is going to be 1. Now, you're going to break this up. Remember, when you have a three-part inequality, this is something you can write using the keyword and so things have to work in both when you have the keyword and. The first one here is going to be really simple. We have the absolute value of 2x minus 1, and then we're saying this is greater than or equal to negative 7. So it's greater than or equal to negative 7. Then I'm going to say and. We're going to say the absolute value of 2x minus 1, this is less than or equal to 1. Now this one right here, I think you can eyeball that and see that it's going to work for all real numbers, okay? Because the absolute value operation is always going to give you something that is 0 or positive, so basically non-negative. And so that is always going to be greater than some negative 7. So this guy right here is all real numbers. Let me just write this. So all real numbers. So then we have this keyword and. Okay, so basically, because this is all real numbers and there's an and here, I'm just going to take the solution from this one as the solution for the problem because it has to work in both. We have the absolute value of 2x minus 1, and this is less than or equal to 1. So this is going to split up into 2x minus 1 is greater than or equal to negative 1, and we'll say and less than or equal to positive 1. So this is pretty quick to solve. We're just going to add 1 to each part here. So basically, this cancels, and you get 0 is less than or equal to. This is going to cancel. You get 2x, and this is less than or equal to. 1 plus 1 is going to be 2. Now here you can divide each part by 2. And basically, let me actually just erase this. We don't need this information anymore. We'll say that 0 divided by 2 is 0, and this is less than or equal to. We have 2 over 2, which is 1, so this is x, which is less than or equal to. 2 over 2 is 1. So this tells me that x is going to be anything that's greater than or equal to 0 and less than or equal to 1. So basically, you would write this like this. So you say all real numbers from this one. Then you say and. You have x is greater than or equal to 0 and less than or equal to 1 from this one. Again, because you're using the keyword and, you have to use this one as your solution because it has to work in both. Okay, so coming down here, let me make this a little bit better. We would say in interval notation, so basically 0 is included up to and including 1. So you have a bracket next to each. And then this is going to be kind of tight to fit this here, but basically you want a bracket at 0 and a bracket at 1. Again, you can always use a filled in circle if that's what your book does. And then just shade everything in between. So x can be 0 or anything going up to and including 1. So graphically, a lot of programs won't actually do this or you'll get trouble with it. But I've sketched a little graph here just so we can think about it. So this part right here is just this guy right here, right? If you punch that in, you could even say that y is equal to the absolute value of 2x minus 1. And then basically you have plus 3. And maybe we'll make this a little bit shorter here. And then essentially you're saying, where is this less than or equal to 4? Well, again, look at the y values. Here's 4, right? So let me actually get rid of this. I think it's in the way here. So here's 4. And this is where it crosses, and this is where it crosses in terms of having a y value of 4. So come down here. This is an x value of 0, and this is an x value of 1. So you can see that if you're between 0 and 1, the y value is going to be less than 4. If you're at an x value of 0 or you're at an x value of 1, the y value is 4. Okay, so basically our solution, if you're saying, where's this guy less than or equal to 4, it's x is greater than or equal to 0, okay, so starting here, and then less than or equal to 1, so ending here. All right, let's take a look at problem number 7 now. So here we have the absolute value of x minus 2, then minus 3. This is less than or equal to 2. So again, another nested absolute value problem. So just think about this guy right here, the expression inside of the outer absolute value bars. Again, you can just think about that as being u. So if the absolute value of u is less than or equal to 2, then u is greater than or equal to negative 2 and less than or equal to positive 2. So let's just write this out. So we would have the absolute value of x minus 2, then minus 3, and this is going to be greater than or equal to negative 2 and less than or equal to 2. Okay, so let's work on this now. So this is a three-part inequality at this point. We're going to end up splitting it. But for right now, let me add 3 to each part to make this a little bit easier to work with. This will cancel. We'll have negative 2 plus 3, which is 1. And this is less than or equal to the absolute value of x minus 2. And then this is less than or equal to 2 plus 3 is going to be 5. Okay, so what I'm going to do now is split this up using my keyword and. So I'm going to say that the absolute value of x minus 2 is greater than or equal to 1. Then I'm going to say and the absolute value of x minus 2 is less than or equal to 5. So this is more challenging, or I would actually say more tedious than the last problem, because in the last problem, we had something with a solution of all real numbers, so we really only had to take the solution from the problem on the right. But here we're going to see that we have to do some combining. So on the left, if you have the absolute value of x minus 2 and it's greater than or equal to 1, you would say that x minus 2 is less than or equal to negative 1, or x minus 2 is greater than or equal to positive 1. So for this one, let's add 2 to each side. This would cancel. You get x is less than or equal to. If you have negative 1 plus 2, that's just going to be 1. And then over here, let's add 2 to each side. This will cancel. And you're going to get or x is greater than or equal to 1 plus 2 is 3. So that's for this one right here. Let me scooch this up here so we can keep this more organized. So you have x is less than or equal to 1, or x is greater than or equal to 3, okay? But you've got this keyword and, so let's work on this. You have the absolute value of x minus 2, and this is less than or equal to 5. So this one has the setup where we say x minus 2 is greater than or equal to the negative of 5 and less than or equal to 5. Let's add 2 to each part here and cancel this. So let's say negative 5 plus 2 is going to be negative 3, and this is less than or equal to. You'll have your x here. We'll say which is less than or equal to 5 plus 2 is going to be 7. And I'm going to put the keyword and here, and this is going to be a little bit complex to figure out. So let's grab this, and let's start with this guy up top. So if you had x is less than or equal to 1, I'm going to use a filled in circle here. I normally don't do that. I normally use a bracket, but I'm going to do that in this case. And I'm going to shade everything to the left here, okay? Then x is greater than or equal to 3. I'm going to come to 3, filled in circle, shade everything to the right. So thinking about this one, we have x is greater than or equal to negative 3 and less than or equal to 7. So at negative 3, I would put a filled in circle, and at 7, I would put a filled in circle, and I would shade everything in between. Okay, so now you're thinking about the intersection or the overlap. Well, this negative 3 would be included, and this 1 would be included, and then this 3 would be included, and this 7 would be included. But basically, it's just those areas, right? Let's get rid of this. We would shade between here and between here, okay? So let's get rid of this. I think we can see the solution graphically and then put it together. So basically, you would say that x is greater than or equal to negative 3 and less than or equal to 1. Then or x is greater than or equal to 3 and less than or equal to 7. Okay, so that's your solution there. And then in interval notation, you're going to put a bracket next to negative 3. This is going up to and including 1, so you want a bracket there. And the union with, again, everything's going to have a bracket, so the 3 and the 7, because they're both included. Okay, so this is your interval notation. Now, I like to use brackets when I graph these guys, so I'm just going to switch this over. This is a perfectly acceptable way to do this. It's just not the way that I'm used to. So I'm going to put a bracket at negative 3 and put a bracket at 1. And then I'm going to put a bracket at 3 and a bracket at 7 and just shade everything in between there. So graphically, x can be anything starting from negative 3, going up to and including positive 1, or it could be anything starting with 3 and going up to and including 7. So once again, thinking about this graphically, you can get rid of this part right here. And I'm just going to say that y is equal to this. This was the left side. And so basically, that's this graph here. And you want to see, where is it less than or equal to 2? So where is the y value 2 or lower? So we can see that if we go here, this is at negative 3. If we go here, this is at positive 1. If we go here, this is at positive 3. And then if we go here, it's at positive 7. So you would see that between an x value of negative 3 and an x value of positive 1, the y value is 2 or less, right? So that's this part right here when you look at the graph. Okay, so let me write x is greater than or equal to this negative 3. And we'll say and less than or equal to 1. Now, as you move to the right here, between 1 and 3, right, not including either one, you're going to be above 2. But then when you hit 3, you're at 2 in terms of the y value. And then as you continue to the right, as your x values increase, going up to and including 7, you're going to either be below 2 or equal to 2 when you get to 7, right? So you can say again, or x is greater than or equal to, again, this 3, and less than or equal to 7. All right, let's take a look at problem number 8 now. So here we have the absolute value of x squared plus 3x minus 4. And this is less than or equal to 6. So again, we didn't do an example of this in the lesson, but we can just use our rule. We say the absolute value of u is less than or equal to 6, where u is x squared plus 3x minus 4. well, then u is going to be greater than or equal to negative 6 and less than or equal to 6. So just set this up and say that we have x squared plus 3x minus 4. That's going to be in the middle. We'll say this is greater than or equal to negative 6, and then and less than or equal to 6. Okay, what I'm going to do, since this is a 3-part inequality, I'm just going to add 4 to each part. I think that's going to make it a little bit easier. So this is going to cancel, and you'll have x squared, then plus 3x. We'll say this is greater than or equal to negative 6 plus 4 is going to be negative 2. And then over here, 6 plus 4 is going to be 10. So we'll say this is less than or equal to 10. So I'm going to split this up using the keyword and. So I'm going to first say that x squared plus 3x is greater than or equal to negative 2. Let me slide this over a little bit. And then I'll say and. We'll say that x squared plus 3x is less than or equal to 10. Let's start out with our guy on the left. And what I'm going to do is just add 2 to both sides of the inequality. So this is x squared plus 3x, then plus 2 is greater than or equal to 0. And then for this guy here, I can factor this. If you want two integers whose sum is 3 and whose product is positive 2, well, that's 2 and 1, right? So I can say this is x plus 2, that quantity times the quantity x plus 1, and this guy would be greater than or equal to 0. We know if we solve a quadratic inequality, the first thing you do is find the critical values. So you can just factor this like this. So x plus 2 here, and then x plus 1 there. And we'll just say this is equal to 0. So you would say x plus 2 is equal to 0. You would solve that. You get x is equal to negative 2. You would say x plus 1 is equal to 0. You solve that. You get x equals negative 1. Okay, so let's grab everything. You want to come to your number line. You don't need this anymore. So then that's your critical value of negative 2. Let's put a vertical bar. And then also at negative 1. So anything less than negative 2, let's say that's A. Between negative 2 and negative 1, that's B. And anything greater than negative 1, that's C. So you have A, B, and C. So you're just going to test inside of each. So we know here, because this is non-strict, that negative 2 and negative 1 would be included. But let's just think about something that's in A. So let's pick negative 3. So negative 3 plus 2 is going to be negative 1. And then negative 3 plus 1 is going to be negative 2. The main thing here is that it's a negative times a negative, which is a positive, which is always greater than 0. So this is true. You could also just say that negative 1 times negative 2 is 2, and 2 is greater than 0. So that's good to go. Okay, so for B, we're between negative 2 and negative 1. Now you could use something like negative 1.5. And again, if you don't want to go through the calculation, just say, is it going to be negative or is it going to be positive? Well, negative 1.5 plus 2 is positive 0.5. So let's just say this is positive. And then negative 1.5 plus 1 is negative 0.5, so this is negative. Positive times negative is negative, and a negative is not going to be greater than 0 or equal to 0, so here it's going to be false. Now in C, we can use 0, and so this would be positive 2, and this would be positive 1, so it's 2. Again, you can just think about the fact that this is positive times positive, which is positive, and a positive is greater than 0. You can say 2 is greater than 0, however you want to think about this, but this is true, okay? So we know that for the solution for this inequality now, that basically x can be anything that's including negative 2 or less, so x is less than or equal to negative 2, then or x could be anything that includes negative 1 or is greater, so greater than or equal to negative 1. Okay, let's grab this, and I'm just going to come back over here and put this right here. I'm going to use my keyword and then I'm going to look at the solution for this one. So let's put this down here. We're going to have x squared and then plus 3x. I'm going to subtract 10 away from each side. So minus 10, this is less than or equal to 0. And let's just factor this. I think it's a little bit easier that way. So let's put an x here and an x here. And let's think about two integers that sum to 3 and have a product of negative 10, where you can go positive 5 and then negative 2, right? So if you set this up as this quantity x plus 5 times the quantity x minus 2 is equal to 0 to get the critical values, you solve x plus 5 equals 0. Well, that's going to be x is equal to negative 5. And then you solve x minus 2 is equal to 0. That's going to be x is equal to 2. So let's grab everything. And coming down here, we don't need this anymore. Get rid of that. Your critical values here, you've got 1 at negative 5, and then you've got 1 at positive 2. So let's say this is A, this is B, and this is C. So let me write out A, B, and C. So let's first start out in A, and I'm just going to pick, let's say, negative 6. So again, you can just work with the sign if you want. So you'd have negative 6 plus 5, that's negative 1. And then negative 6 minus 2 is negative 8. Again, negative times negative is positive, and a positive is not less than 0, and it's not equal to 0. So we would say here this is going to be false. Again, if you wanted to say negative 1 times negative 8 is 8, and 8 is not less than 0, that's another way you could do it. Okay. In B, I'm going to pick 0. So this is 5, and then this is negative 2. Positive times negative is going to be a negative, and a negative is always less than 0, so this is true. Or again, you could say this is negative 10, and that's less than 0. It's true either way. Okay. For C, you could pick 3. So 3 plus 5 is 8, and then 3 minus 2 is 1. And again, this is going to be a positive, and that's not less than 0, so this is false. Okay. Again, you could always say that this is 8, and 8 is not less than 0. So let's write our solution. Here, it will basically be that x is greater than or equal to, it would be equal to negative 5 because this is non-strict, and less than or equal to this 2, again, because it's non-strict, the 2 would be included. Let me stack this up here so that it fits, and let me paste this in here. Okay, so let's consider this. Remember, this is an and for the whole thing, so I'm just going to grab this and go back to the number line, and we're going to think about where this works. Okay. So first off, I'm just going to graph this. So x is less than or equal to negative 2. So let me put, at negative 2, I'm just going to put a filled in circle. I don't normally do that, but for this one, I think it's easier. And I'm going to shade everything to the left. And then for negative 1, let's use a filled in circle there. And then since it's a greater than or equal to, let's shade everything to the right. For the other guy, you have x is greater than or equal to negative 5 and less than or equal to 2. So at negative 5, I would put a filled in circle. At 2, I would put a filled in circle. And again, I would just shade everything in between. Now, where's the overlap or the intersection? Well, this negative 5 would be a filled in circle there. This 2 would be a filled in circle there. And then basically, what I would want to do is grab those guys in between, right? So let me get rid of this. And so I'm just going to shade between negative 5 and negative 2, and between negative 1 and positive 2. So our solution, if you wanted to write it, you would say x is greater than or equal to negative 5 and less than or equal to negative 2. Then you would say, or this would also work if x was greater than or equal to negative 1 and less than or equal to 2. Okay, so this would be our full solution here. In interval notation, you would just put a negative 5 next to a bracket, then comma negative 2 next to a bracket. They're both included. And the union with, let me make that symbol a little bit better. So we would have a negative 1 next to a bracket, and then comma a 2 next to a bracket. Okay. Now graphically, we have this already. I prefer to use a bracket versus a filled in circle. If you like the filled in circle, you can stick with that. It's just not what I usually do. So I want a bracket at negative 5 and a bracket at negative 2, and then a bracket at negative 1 and a bracket at 2. So let me make this a little bit better. I'll just use this same color. So basically, x can be any number that is negative 5 and going up to and including negative 2, or any number that starts with negative 1 and going up to and including positive 2. Okay, so once again, I'm just going to look at the graph with you. We have graphed the left part of this. We're trying to figure out where that's less than or equal to 6. So let me just say that this right here, you could just punch this into Desmos, or you could say y is equal to this. Either way, it'll give you the same graph. But essentially, you see a y value of 6 here. And let me put everywhere where it intersects. So here, and here, and here, and here. And so if you're thinking about where this guy is going to be less than or equal to 6, well, it's equal to 6 at an x value of negative 5, at an x value of negative 2, at an x value of negative 1, and then at an x value of 2, okay? So less than negative 6, you would say between negative 5 and negative 2. So x is greater than or equal to negative 5 and less than or equal to negative 2. And then between negative 2 and negative 1, you can see it goes above 6, right? So we're not interested in that piece. We're interested in this piece here, though, starting at negative 1 and then going out to and including this positive 2, right? Everywhere there, it would be either 6 or less than 6. So we'll say, or, again, x is greater than or equal to this negative 1 and less than or equal to positive 2. So that's how you can get your solution graphically. Again, we're interested in everywhere where this guy is going to be less than or equal to 6. So that part right there, and then also this part right here for your graph. All right, let's take a look at problem number 9 now. So here we have the absolute value of 5x minus 2. This is over x minus 1, and this is greater than 1. So we're going to use our rule and say if we have some algebraic expression u, and that's greater than some positive number, let's just use 1, then here u is going to be less than negative 1, or u is greater than 1. So we're just going to use that here, and we'll take this guy, which is the 5x minus 2 over x minus 1. That'll be our u. So we'll say it's less than negative 1. Then or, we'll grab this guy again. So 5x minus 2 over x minus 1, and we'll say it's greater than 1. Okay. So now that we have this set up, we know that this is a tedious process. We have to solve two of these guys. I'm going to start with the one on the left. Remember, you want to get one single rational expression on the left, and you want 0 on the right. Okay, so that's the first step. So I would add 1 to both sides of the inequality. I would say this is 5x minus 2 over x minus 1, and then plus 1, and this is less than 0. So I just added 1 to both sides. Now, you need to get a common denominator going, and since this is 1, I can just multiply by x minus 1 over x minus 1. So in other words, I can just write this as x minus 1 over x minus 1. And since we have a common denominator now, I can actually just get rid of this and just extend this and just go plus here. So simplifying this, 5x plus x would be 6x. And then negative 2 minus 1 would be negative 3. Let me actually just erase this, and I'm just going to write this more neatly up here. So the numerator is 6x minus 3, and your denominator is just the x minus 1. Okay. When we think about this, we want to find the critical values. So this is where the numerator is going to be equal to 0 or the denominator is equal to 0. So we say 6x minus 3 is equal to 0. We solve that. And basically this gives us that 6x is equal to 3. Divide both sides by 6. This cancels. You get x is equal to a half. Okay, so that's your first critical value. Now, if we had a non-strict inequality, this would be part of your solution. You could just notate that if you want. Because this is a strict inequality, here when you plug this in, this 1/2, the numerator is 0, the denominator is not 0, so 0 over some non-zero number is 0, and you get 0 is less than 0, which is a false statement. Okay, so this is not going to work as a solution. And the other guy, where we say x minus 1 is equal to 0, the solution here, if we add 1 to both sides, we're going to say x is equal to 1. Now that guy right there is definitely not going to be a solution because that results in division by 0, right? So if we made a domain statement, we would say it's the set of all x such that x is not equal to 1. Okay, so let's grab this real quick, and we'll just come to a little number line and test. I'll say this is 1/2 and this is 1. You can get rid of this now. And again, we know they're both not going to be included. And you could factor this. This would be 3 times the quantity 2x minus 1. So let me write this like this. So 3 times the quantity 2x minus 1. Just easier to plug stuff in. So let's say this is A, anything less than a half. B is between a half and 1, and C is greater than 1. So we have A, B, and C. And let's first test an A. So I can pick 0. So 2 times 0 is 0. So basically you would have negative 1 times 3, which is negative 3. This would be over. You have 0 minus 1, which is negative 1. And so a negative over a negative is a positive, and so a positive is not less than 0, so this is false. And again, you can always just say that negative 3 divided by negative 1 is 3. 3 is not less than 0, whatever you want to do. So for B, I need something between 1/2, or you could say 0.5 and 1. You could pick 0.75. I know that's hard to work with, but let's just use a calculator. So let's just say that's 0.75. You could also say 3/4. Let's go 0.75 there. So 2 times 0.75, that's 1.5. Then minus 1 is 0.5, then times 3 is 1.5, right? So you could say 3/2 or 1.5, whatever you want to do. Then this is over. Let me actually just get rid of this. 0.75 minus 1 is negative 0.25. Now, you don't even need to know what the result of this is because you know it's going to be negative, right? And a negative is always less than 0, so this is true. If you did punch this into your calculator, you would get negative 6. So you could just say negative 6 is less than 0. That's a true statement. So either way. Then for C, let's just pick 2. So 2 times 2 is 4. 4 minus 1 is 3. 3 times 3 is 9. And this is over. 2 minus 1, that's going to be 1. So this is 9, or a positive value. And that's not going to be less than 0. So this is false. So your solution here is between 1/2 and 1 with neither included. So we'll say x is strictly greater than a half and strictly less than 1. Okay, coming back here. So I'm going to put that as the solution for this one. And then we're dealing with this one now. So let me put my keyword or. So I'm going to have this 5x minus 2 over x minus 1. Now I'm going to subtract 1 away from each side of the inequality. So minus 1 over here is greater than 0. So this, again, you could just write as x minus 1 over x minus 1. Because this is subtraction, let me take the time to do an additional step here because a lot of people get lost. So let's say this is 5x minus 2 and then minus the quantity, x minus 1. Because this whole thing needs to be subtracted away. So I'm going to put the subtraction sign and then put the x minus 1 inside of parentheses. Then this is over the common denominator of x minus 1, and this is greater than 0. All right, so let's write this as 5x minus 2, and this would be minus x and then plus 1. So 5x minus x would be 4x. So this is 4x, and then negative 2 plus 1 would be negative 1. So this is 4x minus 1 over x minus 1. And again, this is greater than 0. So what are the critical values here? Well, we would set the numerator, 4x minus 1 equal to 0, and solve that. Let's add 1 to each side. This would be 4x is equal to 1. Divide both sides by 4. Let's cancel this and say x is equal to 1/4. So that's one critical value. And again, this is going to be excluded because this is a strict inequality. You would end up with 0 is greater than 0, which is false. So let's put this over here. The other one is the x minus 1 that we saw earlier. If we set that equal to 0 and solve, we get x equals 1. So x equals 1. And remember, this is automatically excluded because it makes the denominator 0, so it would violate the domain. So let's grab this. So we'll come down here and test. So this is 1/4, and this is 1. So let's think about this as a, so anything less than 1/4. This is b, anything between 1/4 and 1. And this is c, anything greater than 1. Okay, so in A, you could pick 0. And again, you could just think about the sign. This is really easy. This would go away. You'd have negative 1, or just a negative, over. This would be negative 1, or just a negative. And a negative divided by a negative is a positive. And a positive is always greater than 0. So for A, this is going to be true. Again, if you want to calculate the value, you can do that as well. This would be negative 1 over negative 1, which is 1. And 1 is greater than 0. So either way. Now for B, I would just use something like 1/2, or you could say 0.5. So 4 times 1/2 is 2, and then 2 minus 1 is 1. So you could say it's 1, or you could just say it's positive. Then additionally, if I did 1/2 minus 1, that's negative 1/2. More importantly, it's negative, right? So positive over negative is negative. A negative is not greater than 0, so this is false. Again, if you want to calculate that, 1 divided by negative 0.5 would be negative 2, and that's not greater than 0. Okay, for C, let's just use 2. So 4 times 2 is 8. 8 minus 1 is 7. Or again, you could just say it's positive. And this is over. 2 minus 1 is 1, right? So you would say positive over positive is positive. That's greater than 0, so this is true. Or you could just say 7 over 1 is 7. 7 is greater than 0. That's true. So either way. So we know that the solution here would be anything where x is less than 1/4, or anything where x is greater than 1. Okay, let's grab this. And we'll paste that in there. And basically, this is our solution. So putting this together, it might be more helpful to graph it before you do your interval notation. So if you look through, you're going to see 1/4, 1/2, and 1. Okay, so you need a notch for 1/4, you need a notch for 1/2, and you need a notch for 1. So if you're using something generic like this, don't worry too much about the spacing. Just make sure it's in the order of the number line. So in other words, 1/4 is the leftmost value, 1/2 is the middle value, and 1 is the rightmost value, or the largest value. So now thinking about this part right here tells me that x is less than 1/4. So let me just start with that. Graphically, I would put a parenthesis at 1/4 to show it's not included, and I would just shade everything to the left. So that takes care of that. Then I'm going to say or. I'm just going to get rid of stuff as I go. You have this part right here where x is greater than 1/2 and less than 1. Okay, so what does that look like? Well, I would put a parenthesis at 1/2, and I would put a parenthesis at 1. That color's not going to show up there, so let me change. And then I would shade everything in between here. Okay, so that would be that part there. Then you have this or. Let me get rid of this so far. You have x is greater than 1. So x is greater than 1. Okay, so for that one, let me use a different color here, maybe this red. And so I'm going to put a parenthesis facing to the right here, and then I'm just going to shade everything to the right. So 1 is excluded, and if you go back to your original rational expression, remember the denominator was x minus 1, and if x minus 1 was set equal to 0, you get a value of 1. In other words, if you plug 1 in, you're going to get division by 0, and that's not defined. If we come to the graph, you're going to see at 1, you have this strange behavior where the graph is going to approach an x value of 1, but it's never going to quite get there. Okay, and this is called an asymptote, and we'll talk about this later on in the course. For right now, let's go back, and let's think about this guy in interval notation. So basically, I would start with this one. So you have from negative infinity going up to and excluding 1/4. so a parenthesis with each. And then the union with, you have anything between 1/2 and 1. So basically a parenthesis next to 1/2 and a parenthesis next to 1. And then basically a union with anything that's greater than 1. Okay, so a parenthesis next to each. So nothing here, when you go through, is actually included. That's why there's a parenthesis basically everywhere. And if you wanted to replace this with an open circle instead of the parenthesis, that's fine in each case, right? So that's what a lot of books will do. I'm just used to this notation. So this would be your full answer. This is graphically, so anything less than 1/4, or anything that's between 1/2 and 1, or anything greater than 1. All right, so additionally, if you want to come back to this graph and think about it, if you punch in this guy right here, this left side into Desmos, or you could just say that y is equal to this, it'll produce the same graph. Essentially, you're looking for where the y value is greater than 1. Not equal to 1, but greater than 1. It would be equal to 1 here and also here, right? So essentially, if you come down here, and this is not going to be perfect, this x value here is 1/4. And then this guy coming down here, this is going to be 1/2. And so essentially, you'll see that anything to the left of an x value of 1/4, well, the y value here is going to be greater than 1. So that's where we got the x is less than 1/4 part. Then we said or. Well, here, anything that's greater than 1/2, you can see that the y value would be greater than 1. But there's a problem. We keep going up, up, up like this because, again, at an x value of 1, you're dividing by 0, right? So that's why we can never actually obtain an x value of 1. So you have to say that x is greater than 1/2 and less than 1, right, to account for that fact. But anything greater than 1 starts to work again. Okay, so we're just going to exclude 1. So we'll say or x is greater than 1. So that's how you could get your solution graphically. Again, you can always just use something like Desmos to see this for yourself. All right, let's take a look at problem number 10 now. So here we have the absolute value of 2x minus 9 over the absolute value of x plus 3. This is less than or equal to 1. Now, the first thing I'm going to do is use a rule that we talked about earlier in the course. So if we have something like the absolute value of a over the absolute value of b, this can be written as the absolute value of a over b. Okay, so we're going to make this little change here. So we'll say this is the absolute value of this 2x minus 9 over the x plus 3 here. And we'll say this is less than or equal to 1. So now we're going to use a different rule. So if we had the absolute value of u, and we said this is less than or equal to 1, well, that means that u is greater than or equal to -1 and less than or equal to 1. Okay, so I'm not going to write this as a 3-part inequality. I'm going to break it up and use the keyword and. I think that's going to be a little bit better here. And so I'll take this guy, this 2x minus 9 over x plus 3, and I'll say that it's going to be greater than or equal to -1. And then I'll say and this 2x minus 9 over this x plus 3 is going to be less than or equal to +1. All right, so we're just going to solve each part separately, and then we'll join our two solutions with and. So for this one, I would add 1 to both sides of the inequality. You're going to get 2x minus 9 over x plus 3. And then I'll go plus 1 here, and that's greater than or equal to 0. Now let me slide this down. This is pretty easy. If you just have a 1, well, then I can multiply this by x plus 3 over x plus 3 so that I have a common denominator. That's pretty straightforward. And then basically 2x plus x would be 3x. So this is 3x. And then -9 plus 3 is going to be -6. And this is over your common denominator of x plus 3. And let's think about our critical values now. So you'd set the numerator equal to 0. So you'd say 3x minus 6 is equal to 0. Add 6 to both sides of the equation. This cancels. We get 3x is equal to 6. Divide both sides by 3. You get x is equal to 2. All right, so that's one critical value. We'll say x is equal to 2. And I would note here, because this is non-strict, that 2 is going to work. The other guy, you'd set x plus 3 equal to 0. You'd solve that. You get x is equal to -3. We know that this is not going to work because this would result in division by 0. So let's go to the number line now, and we're just going to test. Now, you could factor this to make it a little bit easier. So if you pull out a 3, you'd have x minus 2 inside. Again, it's not necessary, but just something I like to do. So 3 times the quantity x minus 2. And then essentially you have the critical value here of -3 and then 1 of 2. And then let's go ahead and set up this and say this is A, so anything less than -3. This is B, between -3 and 2. And this is C, anything greater than 2. So thinking about this, I'm going to start in A, and I'll just pick something like maybe -4. I think that'll be easy to work with. So negative 4 minus 2 is going to be negative 6. And then negative 6 times 3 is negative 18. This is over. If you have negative 4 plus 3, that's going to be negative 1. Now we know that a negative over a negative is a positive. So this is basically a positive 18 here. And of course, a positive is always greater than 0, or you can say 18 is greater than 0. So this is going to be true. Okay, for the next one, you're going to be between negative 3 and 2, so you could pick 0. So 0 minus 2 is negative 2, and negative 2 times 3 is negative 6. And this is over. Here, this would go away. You just have 3. So negative 6 over 3 is negative 2. So this is negative 2 is greater than or equal to 0, which is going to be false, right? So you could say that any negative is never going to be greater than 0 or equal to 0. So that's why that's not going to be true. Okay. For C, you could pick 3. It's anything greater than 2. So 3 minus 2 would be 1. 1 times 3 is 3. And this is over. If you have 3 plus 3, that's 6. So 3 over 6 is going to be a half. But more importantly, it is a positive value, so it's greater than 0. So this is going to be true. Okay. We're going to get rid of this. And I want you to recall that 2 is part of the solution, but negative 3 is not. So we're going to say that in region A, things are going to work, but negative 3 is not included. So x is strictly less than negative 3. Then or. In region C, things are going to work, and 2 is included. So x is greater than or equal to 2. Okay, so let's put this in right here, and then I'm going to write my keyword and we're going to think about the solution for this guy right here. So let me write this. So we have 2x minus 9 over x plus 3. I'm going to subtract 1 away from each side. So minus, and I'm going to write 1 as x plus 3 over x plus 3. So I have a common denominator, and this is less than or equal to 0. What you want to do here is write 2x minus 9, then minus this quantity here. Okay, you're subtracting the whole thing away. So the quantity x plus 3, and this is over your x plus 3. Let me make this 3 better. And then we'll say this is less than or equal to 0. Okay, I'm going to get rid of this. And so this would be negative x and then minus 3. So 2x minus x is x. And then negative 9 minus 3 is going to be negative 12. And this is over your x plus 3. So your x plus 3. And of course, this is less than or equal to 0. Now, for the critical values, if you put x minus 12 equal to 0 and you solve that, you get x equals 12. And we already know this one. This is x is equal to negative 3. Now, 12 is going to work because this is a non-strict inequality, but negative 3 is still not going to work because that's division by 0. So coming back down here, let's put this as negative 3. Let's put this as 12. Let's get rid of this. And let's say this is A, B, and C. So A, B, and C. So let's see what we have here. All right, for A, let's maybe pick negative 4. So negative 4 minus 12 is negative 16. This is over negative 4 plus 3. That's going to be negative 1. So is this less than or equal to 0? Well, this is going to be a positive 16. So basically, a positive number is never less than 0 or equal to 0. So this is going to be false. Then for B, you could pick 0. So this is negative 12 over 0 plus 3 is 3. So if you do the division here, you're going to get negative 4. So negative 4, is that less than or equal to 0? Yes, any negative is less than 0. So this is true. Okay, for C, let's pick 13. So 13 minus 12 is going to be 1. And this is over 13 plus 3 is 16. So this is going to be a positive value, and that's not going to be less than 0 or equal to 0. So this is false. Okay, let me get rid of this. I want you to recall that 12 is going to work and negative 3 is not. So we want things in B. So basically x is strictly greater than negative 3 and less than or equal to 12. So let's grab this. Let's bring this back here. Let me move this word and down here. So basically, we're going to think about this with a number line. So we're going to have 3 values that I'm going to put up here. So one is negative 3. The other is 2. And the last one is 12. Okay, so let me think about this one first. So you have x is less than negative 3. So let me just draw that out. I'm going to use an open circle here. I don't typically do that, but for this purpose, I think it's probably better. Then you have x is greater than or equal to 2. So let me put a filled in circle there because that's included. And then let me shade everything to the right. Okay, so that's this one right here. Now let's think about this one right here. So here we're saying that x is greater than negative 3. So greater than negative 3 and less than or equal to 12. So let me put this in right there, and I need a different color. Let me get rid of that and make this a little bit better there. And then I'm just going to shade everything in between there. Okay, so you want to think about the overlap here. And essentially, looking to the left of 2, there is no overlap. You have this guy up here, which is between negative 3 and 2, which is not a solution in the other one. And the other one is anything to the left of negative 3. So this part of the graph, you can forget about it. There's no overlap between the two. And then past 12, there's no overlap. So basically, you're looking between 2 and 12, with 2 and 12 being included. So that is what I want if I'm thinking about my solution. Let me maybe use a different color because that's not showing up so well. So you want between 2 and 12, right? That's going to be your overlap between the two solutions. That's what you have to do when you have the keyword and. So what we're going to say, just erase this, you don't need it, that x is greater than or equal to 2 and less than or equal to 12. So both of these are going to be included. And let me use a bracket here. I'm just going to change the color up completely. So let me use this color. I'm going to use a bracket at 2, or you can keep the field in circle, and a bracket at 12. And I'm going to shade everything in between. So x can be any number, including 2, and going up to and including 12. In interval notation, it looks like this. So you'd have a 2 here with a bracket, and then a 12 here with a bracket. All right, so once again, this is something you want to look at graphically as well. So we're looking for where this guy is less than or equal to 1. So let me put y is equal to this. This is going to produce this graph, or you can just type this into Desmos without the y equals if you want. But look at where it's equal to 1. So you see this one right here, the x value is 2. That gives me a y value of 1. And then also at an x value of 12, that gives me a y value of 1. So anywhere between an x value of 2 and an x value of 12, you're going to have a y value that is less than this 1. Okay, so if you wanted less than or equal to 1, then you would include 2 and 12. So we say x is greater than or equal to 2 and less than or equal to 12. So again, if you're lost on these problems, just go to Desmos or any online graphing calculator, key this in, and look for where it's less than or equal to 1 in terms of the y value.